welcome back to the NeuroElf demonstration series. Now I want to show how you can use the GLM beta plotter to inspect data in your regression analysis. So once again, I'm picking a GLM file, which I'm now taking from the list of recently opened files. I will once again open this GLM file and I will quickly run both a contrast and a correlation. So as a contrast, I'm now picking a contrast that is a complex contrast where two conditions are compared with one another. And I'm just saying compute current, and it will create this contrast map. And additionally, I will run a correlation of this contrast with age. This then leads to a total of 3 maps. One is the contrast map just as it is. It's a plain one sample t-test. The next map is a correlation, which is empty for the most part, and there's just a few spots that might or might not be significant. And the third map is the intercept term, which means it is the same as the main effect, but with taking the variability in the data that is explained by age into account so that it kind of cleans up the data. And this allows you to also use covariate of no interest to clean up a result. Okay, next I'm switching back to the GLM object, which changes the menu so that I have here a little GLM menu, and then I'm picking beta scatter plotter. Now, one thing I can see is that it takes up a lot of space, and the first thing I will thus do is switch back to the main UI and minimize this UI to a much smaller representation so that I can easily browse the data and then still observe the effect. So the first thing that I'm doing is switching back to the VMP and then selecting the correlation map. And now to see how the actual values are, I'm switching to a scatter plot. I'm picking the contrast of interest, which is decrease over look negative, and then I'm picking the covariate of interest, which is age. And then I can eyeball already that, yeah, it seems that there is quite a correlation in the data here, and I can then show a line of best fit, and it will also give me the statistics for this voxel. However, I might be interested in seeing what the statistic is for the entire cluster. So I'm now setting a statistical threshold and create a cluster table. And then under the VOI menu, I can select an actual cluster. And this will update the beta plotter to the average value of this cluster. The beta plotter then also has additional options. For instance, I can display a confidence ellipse, which is a bivariate measure of how much of the data really falls into a 95% bivariate confidence interval. I can additionally display subject labels, and so I can immediately see that maybe for this cluster, subject KS142 might be an outlier. Let me quickly see if I have also another covariate. Yes, so this dataset actually also showed a quadratic effect with age, and I'm now going to run an additional correlation, and I'm picking the same contrast and select age and age squared, and I will then set that I want to see a model where both are added into one common design. It takes a little while to perform the regression, and once this is done, I can then select this updated map, which is then the correlation with the age squared. This already shows quite a bit, and if I now set this to a relatively stringent threshold, I can try to find a cluster, and indeed, if I now select this cluster, which is, I'm going to the nearest cluster peak, I can see that the data really doesn't fall into like a linear regression line, and so This scatter plotter also allows me to plot the best quadratic fit, which actually fits the data really nicely. Okay, that's it for now for the beta plotter. There's a lot of additional features, but I'm sure you can, just explore the options as they are there. Thanks for watching.